a new topic. So just বলে রাখি কি করাইছিলাম. There was this one extra class যেখানে I did this very important experiment. So in case you missed it, I think I uploaded the class as well. Okay, so just in case if you didn't know what's happening, so there's this experiment here where you need to use stationary waves to find out speed of sound. Okay, using sound waves. So the way we do this is using sand. So what you can see here is that you have your container here that contains sand, right? And you take a loudspeaker here and you produce sound. So normally jeta hoy is that as the sound travels in front of this, right, you'll find that the top surface has some vibrations because sound can distort material because sound is a what wave? Mechanical wave, right? However, if you keep changing the frequency, one particular frequency will show up where you'll start to notice this very distinct pattern, operator moton J pattern. Okay, so you'll find that there's this region of like a very low and a high and a low and a high, right? And that's because what has been set up above that sand, stationary waves, right? But the question is, why would stationary waves produce these kind of pattern? So one step further back, stationary waves are waves that consists of these places where the amplitude is the highest, right? What do we call those? Antinodes. And they happen when the waves are what to each other when they interfere completely in phase, and it's known as a constructive interference. These are very important words, right? And this is the place where the waves meet and they create a destructive interference. And a destructive interference is the place where the amplitude is how much? 0, right? So the problem, and I asked this in the online class and you guys were struggling to answer, is that a peak, a shape jeta form hoy, where would it be a node and where would it be an antinode, right? And the answer is that the peak would be a node here. And the volta create that's going to be an antinode. And the reason behind that is, what is an antinode? An antinode is maximum vibration. Maximum vibration means that there's the highest amount of energy available here. And that highest amount of energy will push the particles out from here. It'll basically create a hole there. Like, if you blow air onto the top of a sand, right, surface, where you blow, right, will that rise or fall, right? Because wouldn't that push all the air, like particles out, right? So এখান থেকে particles গুলো সব সরে যাচ্ছে এখান থেকে. এটা তো 2D দেখতেছ, so 3D তে it'll look like a crater. You know what a crater looks like? ওরকম crater মতন দেখতে, আর side দিয়ে হচ্ছে the sand will move out. Okay, yeah, so basically that. And then what's the distance from a node to node or an antinode to antinode? Lambda by 2. And using that information, you can find out the wavelength and frequency. I said so using V equals to F lambda, what can you find? Speed, right? So that's what we did. আমরা দুইটা করছিলাম, আমরা sand নে করছি, and the other one was using microwaves. Microwaves তো এটা করা যায় না, they're not mechanical waves, so they won't really move anything around. So microwaves case, what did you have to use? Like a detector, and you detect the microwave as you move along, right? So yeah, this is what we have done so far. এখন আজকে we'll start a new topic. তার আগে stationary waves একটা wrap up করতে হবে. There's a small thing left, right? So for that, page 54 এর পাশে the blank page to give a heading there. 54 এর পাশে the blank page, okay? Heading of the stationary waves in use or bytes. Stationary waves in use or bytes. There's a question here in the experiment. So we had to find the wave of the stationary wave or the wave making a stationary wave. That's a good question actually. Stationary wave form by right? How do I find the wavelength? I find this from node to node. How much is that? Lambda by 2. What you can maybe you find lambda. Is that the wavelength of your stationary wave, or is it the waves that make the stationary wave? Do you understand my question? They can take a node to node of this is right? And that is lambda by 2. This lambda here, is it the wavelength of the stationary wave, or is it the wavelength of the waves that make the stationary wave? Okay, so the correct answer is stationary waves don't have a wave. Stationary waves, they're not a wave, they're a pattern. They're a constructive interference pattern, right? So this pattern is generated by what? With waves. What waves? Normal waves, like body back. Wavelength আমরা বের করতে পারি। এখান থেকে নোড টু নোড or antinode to antinode or antinode to antinode to antinode lambda dite pare, but that doesn't really make anything because I'll tell you stationary wave into typical wave na. What does a typical wave have? Like a trough and a crest like that, right? Stationary wave into orom na. They're just in one place going up and down like that. They're not moving around, right? So if there's a question, what is the wavelength of a stationary wave? There's actually no answer to that. What is the question supposed to be? What is the wavelength of the wave that made the stationary wave? And ওটার জন্য হচ্ছে আমরা এই যে নোড থেকে নোড ডিসটেন্স বের করব, তারপর ওটা আমাকে lambda by 2 দিবে. That lambda that you see here is the wavelength of which wave? The original wave that made the thing. Okay. Same goes with frequency as well. Okay. The frequency that you see of the stationary wave is actually the frequency of what? The wave that made the stationary wave, right? The only catch here is that amplitude যেটা দেখো ওটা different. এখানে যে amplitude দেখবা, it's what the original wave, double, right? Because এই জায়গা হচ্ছে double to actually not entirely appropriate. Can you tell me why? মানে যদি আমি বলি যে এখানকার amplitude is a double the original wave, right? Why is that inappropriate? Yeah, so the thing is, in a perfect scenario where both the waves are exactly identical, তখন কি হবে amplitude? Double. But as we saw, waves যখন আসে যায়, what do they start to do? Lose energy. And doesn't the amplitude start to go down? So an antinode is a place where you have what amplitude? An antinode is a place where you have what amplitude? Maximum. The maximum may be double. At maximum double with the parade. But it's always going to be the highest amplitude amongst everything. Okay, right. Let's move on to it. Right, stationary waves in pipes. এখানে তোমাদের অনেক question আসে, so we'll focus on this. Okay, এটা বুঝো কিছু কপি করো না. What I'll do is I'll give you like a much more constructed note on this. আগে বুঝার চেষ্টা করি কি হচ্ছে. So this is a very fascinating topic, and জিনিসটা হচ্ছে how can you set up stationary wave in a pipe? So stationary waves কোথায় form হয়? The one we have learned so far, like entire ideaটা কিসের উপরে based ছিল? The one we learned, strings, right? We learned that there are strings and string is stationary wave form হয়, but they're not limited to strings. They can form anywhere, okay? And in different places that they form, they have different features. So on the syllabus, you'll notice syllabus লেখা strictly. You need to know for strings, you need to know for microwaves, and you need to know for pipes, okay? So pipe কেমনে form হয় দেখাই তোমাদেরকে. So let's say you take a pipe like this, okay? And you have like a loudspeaker placed here. A loudspeaker টা হচ্ছে sound generate করবে, and the sound is going to travel through the pipe, okay? So sound wave pipe এর ভিতরে travel করবে এভাবে, and the wave will go like this, and the wave will go like that, hit the boundary, reflect, and come back. As this happens, what is set up here? That's the problem. Not necessarily. The stationary wave always form. That to me sound pathala reflect করে back করবে, and there'll always be a stationary wave. No, right? Isn't there a particular frequency at which it happens? So তুমি যখন এখানে দিবা দেখবা যে sound হচ্ছে, but it's just basic sound reflection হচ্ছে. But then you start to tweak the sound. মানে তোমার frequency vary করতে থাকবা. Frequency vary করতে করতে একটা পয়েন্টে কি নোটিস করবা that as you keep changing the frequency, there comes a particular frequency where you have a very loud sound coming out from it. এখান থেকে খুব loud sound বের হচ্ছে. And if a loud sound is heard at the opening end, right, what might that mean exists there? Antinode. Antinode মানে loudest sound, right? So তার মানে এই opening এ we have an antinode. And we have found that no matter what kind of a wave is set up in any kind of pipe, listen very carefully, the open end, right? This is the open end. The open end is always going to produce a what? Antinode. এটা যদি মনে রাখতে পারো, then you'll have a very easy time in this topic. That whenever you have an open end of a pipe, it'll always produce a what at that open end? Antinode. And the logic is simple because sound entered করে বাড়ি খেয়ে এখানেই তো back করে. And wouldn't that create a constructive interference? I'll give you a better analogy of this. Remember in the string, where was the antinode formed? In the middle, right? কেন middle এ কি generate করা হতো? The wave. এখানে where is the wave been generated? At the open end? So what would the open end eventually form? An antinode, right? And as always, এখানে ওয়েভটা যাবে, বাড়ি খাবে, এখানে এন্ডে গিয়ে বাড়ি খাবে, তারপর রিফ্লেক্ট করবে, and the reflection might be what to the wave that went in, opposite. So this closed end will always produce a what? Node. Okay. এইটুকু যদি মনে রাখতে পারো, you'll find this topic is like, too easy. That an open end is always what? An antinode, and a closed end is always what? A node. Okay. So এখানে একটা node form হবে. And that's how stationary waves are formed in pipes. The sound will reflect at a boundary. Boundaryটাতে কোনো sound পাবা না, আর যেখান থেকে সাউন্ডটা আসছে ওইখানে সবচেয়ে loudest sound পাবা। এখন আমাদের টপিকের রিকোয়ারমেন্ট হচ্ছে এটাকে ম্যাথমেটিক্যালি অ্যানালাইজ করা, like what's happening here in terms of diagram. Or in Cambridge they do go in depth with it. So they okay. So let's try to understand what is the structure of your stationary wave that is formed here. So ki korbo amra? We're gonna draw the stationary wave here. Acha. So can you guys predict what would the structure have to look like for a stationary wave so that a jagay I have an antinode? The open end is an antinode and the other end is a node. Can you tell me what kind of a structure should this wave look like? The wave to dekhte kirokom hobe? Antinode at the opening end and a node at the other end. What would this wave look like? Like 1/4 lambda. Yes. So ami boli ki chacchi ami. Do you remember that we did our stationary waves that look like this? এরকম ছিল, তারপরে যে এরকম ছিল, and এই যে এটা dotted line ছিল, this was the eventual place, right? And this is the eventual place like that. So that's a stationary wave, right? Now, what is this place of the stationary wave? Node. And what is that place of the stationary wave? Antinode, right? I want an antinode here and a node here. What is the shape that the wave should take? এখান থেকে তুমি যদি inspiration now, if that's a node, that's an antinode, right? What would the shape look like here? Yeah, just that part, quarter of that wave. So দেখেন যেটা দেখতে হবে look something like this, that you'll have like a opening there like that, and inside you'll have your stationary wave form here, and this is the smallest stationary wave possible here. Do you agree? এর চেয়ে ছোট করা possible with my requirement যে ভিতরে নোড হবে আর বাইরে অ্যান্টিনোড হবে, এর চেয়ে ছোট করা possible? No, right? এই frequency যেটা form হয় এখানে, the sound that you hear is the first frequency at which a stationary wave forms, right? Do you remember what we call that frequency? The first frequency at which the stationary wave showed up. There was a name for it. The first harmonic, you're not wrong, but yeah, fundamental frequency. Fundamental frequency is the first frequency at which your stationary wave form, right? For stationary wave on a string, fundamental frequency কখন form হতো? এই shapeটা আসলে, remember? That was the smallest possible shape out there. So এই frequency তে যখন একটা wave generate হয়, what do we call that frequency? Fundamental frequency. And we learn that তুমি যদি fundamental frequency multiple এ যেতে থাকো, what starts to show up again? The stationary wave, right? So yeah, this is your fundamental frequency here. We call it F naught, fundamental frequency. A opening tate, what do you have? An antinode, and at this place, what do you have? A node. Are you with me so far? Acha. Can you tell me what is the length here represented in terms of the stationary wave pattern? What lambda does this represent? Lambda by 4. Do you agree? So node to node is how much? Lambda by 2. This is how much of that? Half of that. So lambda by 4, right? Okay. So far, asha kori buchcho tomra. Ekhon my question for you is, when can I have the next stationary wave? And you're going to help me out with this, okay? Je amar next stationary wave ta ekhane kokhon form hobe? Can you tell me what would the pattern look like? 3 by 2 lambda. What would the shape look like? Right, correct. So what will happen here is আমাকে সবসময় মনে রাখতে হবে at the opening what must I have always at the opening an antinode, right? এখন ভিতরে যদি আমি একটা ওয়েভ কে স্কুইজ ইন করে ফেলতে পারি and keep that idea still intact, the problem নাই তো। দেখো what I'm trying to say. This is a complete stationary wave, right? What if I do this, and I also have this. Do you think I'm breaking any laws here in terms of the requirement? Not so. What do I still have at the open end? An anti-node, right? And what do I have at the close end? A node. So now again, what will be set up in my tube? Stationary wave, right? So you need to figure out for me, etar frequency ta koto compared to the original one. How many times is this? It had to chinta kore answer koro because it tricky, but parle, we're done with the topic. So to give an effort, okay? What is the frequency here that would create this shape? By the way, এটার wavelength কত represent করা হচ্ছে এখানে? 3 lambda by 2. মানে আমি এখানে যে numbers কি easy হয় 0.25 lambda, and this is going to be 0.75. Yeah, I don't think 3 by 2 হয়. 3 by 2 হয়. 3 by 4 হওয়ার কথা. Half plus quarter, that's 0.75. ঠিক আছে, 0.75. Right, so can you help me out with what frequency would enable this? মানে কোন frequency তে এটা form হবে? If the original frequency is f naught, right? At what frequency would this form? 2. Sure. 3f naught. আচ্ছা, আমি আরেকটা ড্র করি, তোমরা চিন্তা করতে থাকো। I'll just draw one more. মানে নেক্সটটা কখন হবে? সো নেক্সটটা কখন হবে তোমরা মনে প্রেডিক্ট করতে পারতেছো কি হবে? Sorry. One more node. Yeah, one more complete cycle, right? So এখানে এটা আসবে and এটা আসবে এখানে, and এটা আসবে এখানে. See, I've not broken any laws of wave formation, stationary wave, and if you add all of these up, কত আসে এটা? 5 lambda by 4, which is 1.25, I believe. So বল এখন আমাকে, মানে it's a math question for you, it's not a physics question. Complete the sequence here. If f naught gives you lambda by 4, 3 lambda by 4, 5 lambda by 4, এখানে f গুলো কি হবে? Yes, এটা এখানে আসবে 3f naught আর পরেরটা আসবে 5f naught. And as you can see, stationary waves in pipes, listen very carefully, stationary waves in pipes only form when the frequency is a multiple of what multiple of your base frequency? Odd number, right? String এ কি ছিল? Any number, even 1, 2, 3, 4, 5, right? String এ, the answer is for string. Stationary waves form at what multiple? Whole number multiples. For tubes with one side closed, one side open, what is the multiple? Odd number. What I'm trying to explain here, try to understand this. You don't have to memorize them. Also, you don't need to assume all of them are same. Different setups have their different fundamental frequency sequences. So আমাদের সবগুলো শিখা উপায় নাই. There are so many different scenarios out there. What you need to understand is that it can be different. And exam এ যখন আসে, they will guide you through it. যে ধরো frequency আসছে 70 তে, next to 10, তারপরে হচ্ছে 350. You can figure out what the multiples are, right? 70, 210, 350. তারপর বলবে predict the next one. So next one কি হবে? 70, 210, 350. What's the next one? So, I'm multiplying 70 with numbers, odd numbers. 70, 210, right? 350, 4. Yes, 7 into 70. So many odd numbers, 1, 3, 5. তারপর কি আসে? 7, right? So 7 into 70 তে আসে. Do you get my point? What I'm trying to say? Okay. Anyways, by the way, this is strictly for what kind of a pipe? One side closed, one side open, right? And what you see here is actually the design of a flute. So flute যেমনে কাজ করে, flute এভাবে কাজ করে. You know flutes, right? No, there are different versions out there. I'll show you right now. Also, both ends open. Oh, by the way, do you play the flute? Sometimes I'll need your help. I'm flute button. So you'll have to tell me what's going on in the flute, okay? Right. So let's say মানে flute কেমনে কাজ করে, okay? I'll show you with the practical example the easier হবে. So flute এর মধ্যে there are some openings here and you can close and open the openings, right? Based on which sound would change. I'll show you how it happens, okay? So imagine তোমার হচ্ছে sound generate করা হলো. So একটা জায়গা থেকে you have to blow the air in. That's basically কি হয়? Sound generate হচ্ছে, right? Because the air particles collide here and that's how the sound is generated and the sound waves travel like this, right? And as they travel like this, what will happen is they'll go and hit here at this edge and they'll produce a what at that place? Node, right? And as they try to come back, what do they face on their way out? An opening a key form of it, antinode, right? So তখন কি হবে, you'll have a wave that forms here that looks like this, and that's the first harmonic, right? এখন let's say you put your finger here and you close this finger দিয়ে এটা close করে ফেললা, is that an open end anymore? No, right? Where is the new open end? তার আগে. So the wave will now form this shape, and that would be a what frequency compared to the previous one? Lower frequency. কারণ ওয়েভটা বড় হয়ে গেল না. Now let's say you close this with your finger as well, right? Would this be the open end anymore? No, right? তাহলে কোথায় আসবে open end টা তার আগে? So by opening and closing the gaps, right, what can you manipulate? The frequency, and that's what flutes do. Now open end আমার যদি দুইটা সাইড ওপেন হয়, which is not really part of your syllabus but জানা উচিত, দুইটা সাইড যদি ওপেন হয়, what would you have at both sides? Antinodes, right? And at the center, what would you have? Node. Okay, so এটা দিয়েও করা যায়, but this is easy to understand, that's why I'm using this. Okay, now the most basic flute ever is this one যেটা এখন draw করতেছি. It is a flute that produces one single frequency. Yep. So your whistle is the smallest flute out there. It just produces what frequency? One single frequency. কেমনে কাজ করে? ফ্লুটের মধ্যে when you blow air through this side, sound generate হয়. সাউন্ডটা ভিতরে গিয়ে ওই opposite side কি করে? Bounce করে, and it produces a what here? Stationary wave. And on its way out, isn't that the opening here? So at this place, what will it generate? Antinode. So এখান থেকে কি বের হয়? The loud sound that you hear. Okay, so that's what a flute is. I mean, a whistle is. A whistle is basically one single frequency flute. Now, here's a question for you before I wrap this up. Fluter size, a normal flute, right? Have you seen flutes are like a meter long sometimes, right? Right. আবার একটু ছোট হয়, আর একটু ছোট হয়. Whistle is that small. Can you predict what kind of a sound the whistle make? A low frequency or a high frequency? Why? Yes, because when you have that small of a size for the wave form, wouldn't that form a very small wavelet? And a very small wavelet will mean what frequency? Very high frequency. But if you have a very long tube, what kind of sound would you expect? A very low frequency. Do you know what a didgeridoo is? Yeah, didgeridoo is basically this tube. You know, that's a moment too young. They're quite young, so you know, your fast regardless of the level that they're at. So it's basically a pipe, right? And if you go into a pipe, it's a very annoying sound. What it is. So if I pipe that low, and what is sound low frequency, and it's the obvious why. That is why, by the way, it's a very large flute, right? So if you have a very small size, what's the frequency? Not large. Really low still aggregate waveform, which is one quarter of it. But that's a very large wavelength. So what will the frequency be? Very low, right? আর এটা নিয়ে তোমাদের experiment আছে, মানে I've seen before, এখন দেখি না, we try to do one in the lab. এটা হচ্ছে this particular experiment, let me show you what it does. So what you're supposed just a place where you generate your sound, ওইটা তার back করে না। এখন তুমি যদি সব বন্ধ করে ফেলো, that would become the antinode, because the sound has to come out from there. Sound হবে না, because the whistle designটা হচ্ছে circular, তো the waves will try to move out of that. I don't know if you have noticed, ওদের কিন্তু এরকম একটা এই যে angle করা থাকে whistle, and that ensures that the sound will only go this way, not back to your mouth. আচ্ছা, আমি যে এক্সপেরিমেন্টটা দেখাতে চাচ্ছি, ইটস a very famous experiment, so famous that it comes in your paper 2 as well. এক্সপেরিমেন্টটা হচ্ছে, you take a cube like this, a bread, okay, and what you do is you fill it up with water. ল্যাবে করানো যায়, বাট we have tried it, ওভাবে ভালো কাজ করে না, but I'll see if যদি পসিবল হয় করাবো। বেসিক্যালি আমরা ইউজ করি টিউনিং ফর্ক। ইউ নো হোয়াট আ টিউনিং ফর্ক ইজ? টিউনিং ফর্কের সাউন্ড গুলো অত লাউড হয় না, সো এক্সপেরিমেন্ট অত ভালো হয় না, বাট এটা ইন থিওরি ইটস সাপোজ টু ওয়ার্ক প্রিটি ওয়েল। সো লুক এট দিস, ইমাজিন ইউ টেক এ ব্রেড, রাইট, and তুমি যেটা করবা, উপরে একটা লাউড স্পিকার প্লেস করবা, and you produce a sound here through the loudspeaker, and you place your ear এই জায়গাটায়, so you're basically listening the sound from that location. That's where your ear is, right? So যেটা নোটিস করবা, when your water is full, right, soundটা loud থাকে। কেন? Because isn't the sound coming from here, reflecting here and stuck between that place, so isn't all the sound going to you? Sound কিন্তু পানিতে travel করতে পারে না, like not here, okay? Then what you do is you start to release water, and the water level starts to go down, right? As the water level starts to go down, you start to notice the sounds like, dying out. As a sound, obviously your ear is right next to a loudspeaker, right? But sound the key right? And then suddenly at a particular depth, what happens to the sound? It becomes really loud, like suddenly অনেক volume বেড়ে যায়, right? So the question they ask you is why? Why did the sound suddenly become so loud? কি হলো? Wavelength loudness এ কিছু নাই। Why did the sound suddenly become very loud? As you keep releasing the water, sound কিন্তু কমে যাচ্ছে। Yeah, I mean, that's the only thing possible here, right? Chapter. So what's happening here is you have the formation of a stationary wave here, and stationary wave form হওয়াতে যেটা হচ্ছে, what has happened at the top? An antinode, and because of that antinode, what are you hearing here? A very loud sound, right? Which means আমি যদি একটা স্কেল নিয়ে এই লেন্থটা এখন মেজার করি, right, I'll get how much of that wave? Lambda by 4, and that's actually the experiment that came many years back. You find the wavelength of the sound using this process. ওরা যেটা করছিল, ওরা আরেকটা স্টেপ করছিল, ওরা বলছে কন্টিনিউ টু, মানে গ্রাফ প্লট করতে বলছিল, ওরা বলছিল কন্টিনিউ টু রিলিজ দ্য ওয়াটার। সো আমি পানি যখন আবার ছাড়া স্টার্ট করি, ইট ডিসঅ্যাপিয়ার্স এগেইন। মানে what I'm trying to say is যে আমি যে পানি আবার রিলিজ করি, I'll notice that loudness চলে গেল, and it's gone, it's gone, it's gone, it's gone, and suddenly it's back again. Why is it back again? Yeah, another harmonic has formed right now, right? And ওইখানে তুমি যদি লেন্থটা মেজার করো, this time that length will give you how much of lambda? Yeah, it'll give you 3/4 lambda, and by doing that you can keep multiplying and repeating the experiment to find an average, and you'll find the lambda from there. So yeah, this is the open tube experiment that we had, and that's all you have for tubes and sounds in tubes. Question থাকলে আমাকে বলতে পারো। For sound to travel through liquid, you need to produce sound in the liquid. So you'll notice sonar, for example, sonar transducers are underwater. The problem is the surface of water is very reflective. Like, it reflects light and waves. So whenever sound hits it, it prefers to reflect. It does go in a little bit, but it prefers to reflect. That's why when you're under swimming pool, let's say, and somebody is like screaming outside the swimming pool, it's very difficult to hear the person because the sound doesn't really go inside. Sorry, which one? Which one? Oh, didgeridoo. Yes. Oh, didgeridoo. And the other one. And the vuvuzela. Oh, sure. Yeah, this is your vuvuzela. Oh, no, video তে কিছু দেখার নাই তো। That's the vuvuzela, okay? I can play the sound for you. It's a very annoying noise. What? 14 April market? What is that? Oh, Mela. ওই এটার পর থেকে it became very famous. So yeah, it's not a Bangladeshi culture. It's just a World Cup report thing, it become a thing. Yeah. The other one, the didgeridoo. Yeah, didgeridoo is something else. Oita is its own thing. Let me show you key. It's like a father of this. Yeah. So it produces such a low frequency, it like vibrates your body. Because our body natural bone frequency is 8 hertz. So 8 hertz se oita produce kore, you can feel your bones vibrate. Yeah. Kunta. No, it's like a whistle actually. It can act the gas. But yeah, both sides open. So it produces antinode, and the center it's a node. Okay, let's wrap this up. Let's see some of your questions. Right. When you blow into a whistle very hard, like, with a lot of air, does the sound change? Well, the sound obviously changes, but can you tell me what about the sound changes? The frequency, the wavelength, or the amplitude? When you blow into the whistle very loudly, like, with a lot of force. মানে ওটার frequency change হয় নাকি হচ্ছে wavelength change হয় নাকি amplitude change হয়? আবার বলি frequency is the sound, like, the sound itself is the frequency, right? Wavelength কিন্তু একটা dependent variable, it doesn't really mean anything. আর হচ্ছে amplitude represents what of the sound? Loudness. So তুমি একটা whistle যদি খুব জোরে blow করো, right? সাউন্ডটা চেঞ্জ হয়ে যায় নাকি সাউন্ডটা সেম থাকে, লাউডার হয়? Louder. আচ্ছা, and I'm disappointed that you guys struggle with this because আমি বললাম না ওই শেপটার মধ্যেই তো সাউন্ডটা ফর্ম হয়. If you blow harder, does the whistle get bigger in size or smaller in size? No, right? The same sound you produce করবে. It just you're given more energy. So what happens to the loudness? Increases. Okay, it's like, when you pluck a guitar string, it produces a sound. If you pluck it very hard, it produces what sound? Same sound but louder. Like, amplitude varies. Okay. Yes, it does. In our station wave chapter, we don't look into it, but it does have a factor. And that's the reason why it changes something called the quality of sound. And that's a trumpet produces a very broken sound. It's because of the size of the pipe. And if you have a very thin, narrow pipe, it'll be better. Have you ever seen, like, if you take a glass Coke bottle and you blow at the top, it produces like a tone? Or if you take a glass and you rub water at the surface, it produces a tone. All right, so these are very clear sounds because they're very smooth surfaces. But trumpet is a metal. The metal has its own sonorous properties, so it breaks the sound. So yeah, the shape, the material, a lot of things come into factor. And that's the reason why there's so many musical instruments out there. Is there a note at the end we wouldn't hear anything? Yes, if there was a note at the open end, what would you hear? Nothing, okay, in theory. But in practice, no, because perfect destructive interference are possible normally. Okay. I've seen though in music recording studios থাকে না, ওইখানে যে ওয়ালস এর মধ্যে অনেক হচ্ছে সাউন্ড প্রুফ দিয়ে রাখে, ওদের মাইকটা যে জায়গায় রাখে, that's actually designed to be the node of the whole place. So তুমি যখন সাউন্ডে you produce a sound, right? That place is supposed to be the void zone বলে. But there was a question on this. I didn't know about this. So ওরা বলছিল that void zone theory is actually incorrect. যে তুমি ধরো একটা রুমের মধ্যে একটা জায়গায় তুমি একটা নোড বানাতে পারলা, and that becomes the void zone, মানে এখানে কোনো background noise থাকবে না. Why is it not applicable or why is it not beneficial in the long run? আমার কোয়েশ্চনটা কি বুঝছো? মানে রেকর্ডিং স্টুডিওতে যাও তো one of the biggest problem is the echo, like, বা সাউন্ড সব জায়গা থেকে আসে. So if you could, or movie theater, the question I'm talking about is a movie theater যেখানে একটা জোন আছে যেখানে কেউ বসলে সাউন্ড পায় না. কেন? It's a what point in that movie theater? A node, right? But they said that it shouldn't be a problem actually. One student claimed it's a problem, but they said it shouldn't be a problem. Why? Like একটা নোড যদি হয়, it actually হওয়া উচিত না. নোড হতে পারে, but it shouldn't be a problem. Why? ওইটা একটা recommendation ছিল, but there was another reason. So the reason why a node is not a problem in a movie theater is because nodes are produced based on particular sounds. Movie theater sound কি একটাই sound থাকে? Isn't it continuously changing? So what's happening to the node location throughout? Yeah, it's moving around, right? So you can't have a node at one place all the time. If the frequency is constant, that's possible. Okay. Oh yeah, disclaimer again, pipe দুই side open থাকলে কিন্তু possible to make a sound. Somebody said যে ললিপপের স্টিকে নাকি হচ্ছে whistle থাকে একটা, ওইটার দুইটা side open থাকে. It's possible. That's actually a very good example. That's the two end open stationing wave. Okay, it is possible. How did we find that in a pipe the frequencies are odd number multiples of the wavelength? Which is আমরা যেটা করছিলাম, we found the diagram that produces the stationary waves, and we found them to be, look at this, lambda by 4, 3 lambda by 4, 5 lambda by 4. And you can দেখতেছো that the wavelength is actually decreasing. Just look at this. This is the quarter, and quarter into it too, and quarter into aru choto. So if your wavelength is decreasing, what does that mean with frequency? It's increasing, and it increases at these multiples, 3, 5, 7, odd numbers. Okay, so this is it. I'll add a note here on this. But তোমাদের কোনো question থাকলে আমাকে বলো. We're done with station waves. বলো. Itself, yes. By constricting in the sense, yeah. So let's say my flute is this size, right? And it's a single opening here, and it's closed there, and I make a sound here, right? So it produces a frequency. Let's say I cut my flute and I make my flute half the size, and I again blow a sound here, right? Would it be a higher frequency or lower frequency? Yes. Why? Because now the wave can only form in that small size, and that would be a very small wavelength. A small wavelength would correspond to a what frequency? Right. So if you have any questions, bolo amake eta niye, or stationary waves general, because we're done with stationary waves. I'll be done with waves next week. I'm gonna tinta class lagbe, and then we'll start electricity. Electricity hoye gele our syllabus is over. We last chapter that's bolchi barbar useless. It is useless. এরকম যদি হতো যে অনেক কোয়েশ্চেন দিত তাহলে না ইউজফুল হতো. It is easy and also question that. So what's the point in it? Right. So যে যা বুঝালাম ওগুলা এখানে লেখা আছে. কি? Yeah, actually true. A2 তে দিলে better হতো. edX is in A2. আচ্ছা, let's move on. আজকে নতুন টপিক স্টার্ট করব. এগুলা তোমরা পরে দেখে নিও. ওকে, মানে I'll upload them, তখন কপি করে নিও. যেটা করব এখন, can go to page 56. So just 8.3 is left. It will hopefully not take much time. Right, so this one, I think তোমাদের জন্য easier হয় compared to like edXL students. Or the diffraction all levels ছিল না. You guys had diffraction and you had it pretty well. So এই জায়গাটা আশা করি ঝামেলা হবে না. So can anyone remind me what was diffraction? Yes, it's exactly that. Okay, it is the spreading of waves as they pass through a gap comparable to their wavelength. Okay, so let's say you have a gap that's the size of Dhaka, and your wave is a light laser, right? The gap to Dhaka Shaman, there are two walls, let's say just hypothetically speaking, and you have a laser whose wavelength is 2 nanometer, right? Will that wave diffract as it passes through Dhaka? No, right? So do waves always diffract when they pass through a gap? No, right? So what is the requirement? Yes, তাহলে তো perfect or comparable, কাছাকাছি থাকতে হবে। আচ্ছা, so ওইটা আমরা দেখবো কি হয়। Okay, সবাই স্ক্রিনে দেখো কি হচ্ছে। So you have these three gaps here, and you have your wave coming through here. What I'm drawing is top view, so these are my wave fronts here, and you'll find that as this wave approaches this gap, key hoy to boli. So there's a very interesting physics behind it, which we don't have unfortunately. Waves emerge from points. Okay, so what happens is as the wave comes here, this is energy here, right? This energy will hit this barrier here, and the energy has no place to go, so it'll just go back, and it undergoes what here? Reflection. Same way, energy it hits the barrier here, it has no way to go, so it just goes back. It undergoes reflection. But a small part of this wave, right, that place, the energy can actually seep through. And as the energy passes through, right, not entirety of the wave can pass through. So তার jeta hoy, a very small part of the wave makes its way out. And this wave, as it makes its way out, changes its path, not direction. Actually, জিনিস খুব important, diffraction is not the change in direction of a wave. ওইটার নাম আলাদা. What is that? Refraction. When a wave goes like this and changes the direction, এখানে কিন্তু ওয়েভটা spread হয়ে যাচ্ছে. Okay, so it's getting dispersed. So what you notice here is that the wave makes its way out, but not all of it makes its way out. Some of it does. So you'll find that most of them reflect and go back. This is also called diffraction, but this is not a perfect diffraction. Barely pass, right? Now if I do the same wave and place it here, you find that the gap here is now big enough for a complete wave pass. And what we have now, physics is not a part of syllabus, but it's called the Hudgens principle. When the gap is equal to your wavelength, a full wave can make its way out. And when a full wave can make its way out, what it does is that it spreads out perfectly. Because the entirety of the energy can go out, right? And as a result, you have the formation of this. This is also diffraction, but this is what we refer as a perfect refraction. We find that full circular resistance. Okay, so how do you know that this is happening? So let's say there's a gap, right? And you're standing next to the gap, not in front of the gap. What will you still do? You'll get the wave, you hear the sound, right? It's like a door, let's say, and you're standing right in front of the door. You'll hear the sound, right? As you start to go to the side, the sound does just die out, and at one point you will not hear the sound. If proper diffraction takes place, you'll find that the sound is the same everywhere. And এটা হচ্ছে কিন্তু intentionally use করা হয় in loudspeakers. Loudspeakers এর যে circle থাকে না একটা loudspeaker দেখবা, the big ones, right? ওই circle তে কিন্তু design করা so that the wave passes through that and undergoes what? Diffraction. And where does the sound go? Everywhere. And that's why in a theater, or if you have a theater system, you'll find that the sound is equal loudness everywhere, right? Contrary to what happens in your phone though. Phone কিন্তু purposely design করা that এটা হয় কেন? Because you don't want to bother people next to you. So phone যখন তুমি তোমার phone ধরে রাখছো, you find the sound is coming straight at you, very loud. Anyone who's right at the side of you, sound পাচ্ছে না। একটু angle করলে sound পায় না কেন? Because the design is made so that the sound doesn't spread. You get my point? So you can manipulate the whole size, right? The gap size to allow this to happen. Wi-Fi routers, for example. তুমি তোমার বাসার Wi-Fi routerটাকে কোনো গ্যাপের পাশে রাখো, they can actually maximize the range. it can go through gaps in other places, right? So yeah, that's what diffraction is used for in practical scenarios. Now, what if your wave is too big? তখন কি হবে? So if your wave is too big, তখন যেটা হয় is that most of the waves at the center will be able to pass through. So ওরা যেটা করে এই সোজাই চলে যায়, and some of them at the edge are influenced by the gap. So ওরা edge গিয়ে একটু diffract করে. So it'll be something like this. And the bigger the gap is compared to your wavelength, the smaller this effect is. So at one point, you wouldn't even notice these happen. Okay. So yeah, what's the requirement here, Tale? So for proper diffraction, this is when your gap is less than your wavelength. This is when your gap is similar to your wavelength. This is when your gap is bigger than your wavelength. And you'll find that diffraction happens best when they're similar. বেশি বড় হলেও problem, ছোট হলেও problem. Okay, so if you want to maximize this effect, equal to the best. Like if it's exactly equal, you get the perfect semicircle. All right. So yeah, our next topic will be working with this and incorporating interference with this. ওইটাই হচ্ছে next 2 classes লাগবে আমার, and then we'll be done with waves.